Well, let's get going. Good afternoon. This is Comp 725, software security testing. You probably already know that. Yes, we are talking about cross-site scripting and cross-site request forgery. There's what we're doing today. Actually, that's what we're doing this week. We will not get into cross-site request forgery today. But we should be able to talk about cross-site scripting and redirection attacks, and a little bit about a couple other possible threats. And for both of them, the first thing is to talk about, well, what is it? How is it done? Then how do you detect it? How do you get around being detected? And what do you do about it? Okay. So, yes, and these are a mixture of Dr. Yuan's slides. Actually, I think they were created by her TA and my slides. And so you have to look carefully to tell the difference. All right. We're talking about one user attacking another user, which is just about as effective as one user attacking a system. And again, when we talk about cross-site scripting, the different types of it, and what other attacks you might have. Okay. I might point out that we looked at these before. OWASP is the open web something security something. Yes, OWASP.org keeps a list of the top 10 web application security risks. Here they are. We talked about SQL injection last week, and they include cross-site scripting as an injection attack. And again, both of them are very similar in the sense that they take user-supplied data and they put it in an environment where it gets executed. And so users may, with proper input or evil and valid input, cause the system to execute their data and thereby do something nefarious. Okay, talk a little bit about HTML. Probably all of you know how to make a web page. I don't know how you can get to be a graduate computer science student without knowing something about this. But here's an example. Okay, we have the bracket P, which is a paragraph, and we're missing, no, we're not. It looks correct. Okay, we have an ID. The ID just gives an identifier to this paragraph, which you can use later on if you want to identify it, and we will. And then we have the text, which is mom and apple pie, and then the /P, which of course means the end of the paragraph. So we just have a text paragraph. This will appear on the screen and say mom and apple pie. JavaScript in the HTML, embedded in the HTML, can change that. During the execution, you can get the item. And here you can see the document being the root of the domain object model, which defines all the objects in a HTML page. The method get element ID, passing the parameter thing, which of course is the ID of the paragraph we're interested in. And so that's going to go out and grab an identifier for that document, or the object that represents that document. And then the dot inner HTML says, what, we're going to change the text of the HTML of this object. And we're going to set it to evil and corruption there with the HTML tags, emphasis and end emphasis. And that will display, then to display where you say mom and apple pie, it will say evil and corruption with the word evil being bolded. And that works for HTML tags. You cannot put JavaScript in there. If you put JavaScript in there, it will simply display it. It doesn't execute it in this environment because a text paragraph field is not an executable item. It is text. Okay, but you can, on the other hand, change it a bit. Here we have the same thing, but now we're going to do a document.write. A document.write writes a new HTML page over the existing HTML. It doesn't change, of course, the server's file. It just changes what your browser is going to interpret. You can say, you can append to the end, or you can just rewrite the whole HTML. And that's what we're doing. We're just simply going to change it to the word script evil stuff end script, where evil stuff is some nefarious activity is going to execute and probably do something nasty. And so that, in this case, because write is going to rewrite the whole HTML page, it will then interpret that as it gets to the text here. It will interpret it as script, and it will do the JavaScript that is there for evil stuff. That will be executed in this case. Again, as we mentioned last week, the problem becomes untrusted data. You're getting user data and putting it into an environment where it may be executed. We will talk earlier about it. You do the usual stuff of putting in quotes and stuff where it fools the JavaScript interpreter to think that this is the you ended field and now you have more data, just like we did an SQL injection. So if the untrusted data, which can come from user input, and often does come from user input, but it can come from other places. It can pull out of databases. It can be stored. And one of the attacks we'll talk about is stored attacks, where you put something in a database, and then when it's pulled out by another user and you combine with it, it will cause an attack. It can come from cookies, whatever. And as always, user input or untrusted data should always be treated as if it's an attack, and you should not put it in any place where it gets executed. And again, it's hard to follow because sometimes the untrusted data comes through the application, it gets split apart, recombined, it mixes together and then comes back. And so little pieces can be later recombined into something more dangerous. Okay, cross-site scripting is the topic for today, usually abbreviated XSS. Cross-site scripting is when you enter, when some information, usually user entered or comes in again from any of the sources I mentioned, where it's into an environment where the browsers will execute it as if it's script, as JavaScript. Or, of course, it doesn't have to be Java, by the way. It can be Visual Basic or whatever other script language that your browser is using. There are several that are supported, but JavaScript is by far the most popular one. And so this is a very common attack. As you saw, it was number 3 on OWASP list. It happens a lot. It's a little bit more difficult to stop than SQL injection. As we talked about last week, SQL injection can be stopped dead by using prepared statements that have parameters. This is not as easy because your general HTML mixes together the text and the formatting for it, and the script is all kind of interwoven. And so if user input, which is expected to be displayed, somehow breaks out of the text environment and can become executed, that's where you get the cross-site scripting problem. Cross-site scripting has been around for years. I think Wikipedia told me it started sometime in the mid or late 90s, and the Microsoft security engineers coined the term in the year 2000. So it's been with us for a while. And it's still there. It's still number 3. We haven't really figured out how to secure the web. It should be noted that the reason this class exists is because it's just a dangerous system out there. We haven't come up with a web that's much more secure. I think we could. That's your job. Okay, let's give an example of an attack. All right. So we have a very simple web page, and it asks the user for the name. You enter the name in the input field, and then it sends a GET request to the web server using HTTP GET command. I hope you all understand that. You're getting a no on that GET command. You haven't covered HTTP. My live studio audience is not responding. Have you covered the basics of HTTP before? Yeah. Yes. Okay. He says yes. You say yes. All right. Well, accept that as 2 out of 5 for yes. And the other 3 don't have to wake up. But wait, not to wake up in a minute. So when you have a user input, the GET request sends the data on the command line. So you see, let's see if we can get these pencil drawings to work now. Yes, okay. We're going to execute the myapp.php. The question mark separates the URL and the data, and so the user parameter is set equal to Ken. Okay, so really simple. Going to go out and get Ken, and the website's going to respond. Okay, in that case, the name can be reflected back in the sense that the server will send back a web page, and the web page somewhere in it might say hello Ken. You often see where you enter your username, or maybe if you logged in, it will say hello whoever you are, and it personalizes it, or some data that you've entered is then reflected back. Well, a very common example is if you do a search on Google or whatever your favorite search engine is, it almost always displays the search that you did on the top of the results. So it echoes it back. So here, very simple. It appended the word hello before my name and put it in a paragraph. Easy enough. But now, what if instead of entering my name, we entered some script here? We got the script, and again, we're using alert. Alert is a very simple JavaScript function. It simply pops open a box and shows you, and prints that message. So if you execute this, and so instead of putting my name, so instead of putting hello Ken, it'll say hello, and then script alert got you end script, in which case this box will pop up. Now, the alert message isn't dangerous in particular, but it's an example where at this point we are executing JavaScript. We could have done something really nasty at this point. So at this point, we executed some JavaScript. Here, let's see, get rid of this box, is an example of a very simple web page that goes out there, and that's the HTML stuff. We'll start down here where actually, let me get that. Okay. Okay, down here in the body of the we have just a paragraph and then an input field. That's going to be a little box where you enter text. It's type text, and when you change it, meaning the end of entry, you press enter or something like that, it will call the show names method up here, and it's got an ID and some other stuff. And so up here in the show names, very simple. It simply takes the text, gets the ID, gets the value being what did you type into the input field, and then there's a document rewriting the HTML, saying the word hello and whatever you input. So this, of course, is dangerous. We just looked at it. That's okay. I'm going to reshare my screen here with maybe I will. Yes, hopefully everybody can see the screen. We'll hide this for a minute. And we're going to go down to our browser. Oh, and they made this difficult, didn't they? Well, we'll try it up here.
I can minimize the browser.
I could, but I want to show the browser. This thing is just covering what I want. Okay. You can't minimize if you can't get that. All right. Let's go to my website, which is http://Williams, if I can spell my name correctly, .com. Typing is not good today. .ncat.ed. Oh, geez, okay. There's some hope that maybe I'll be able to type today. mt/comp725/ASG/XSS/ECHO.html. Does that look like it might work? Let's see if it works. Oh, yes, look at that. And just for fun, we will make it, not that big. I get carried away. Okay, so everybody can see it. Oh, so here it is. And this is that very same HTML that we just showed. So if you type in your name, if you type, and then it goes, there's the heading, and it says, hello, Ken Williams. Beautiful, just like we expected. Oh, oh, that's right. Yeah, wouldn't this be someplace else? Okay, all right. I wrote it. All right, but instead of doing that, let's do something nasty. I will put my name in there and then script, alert, parentheses, being violent today, sorry. Oh, nope, I have to type correctly. Let's see what that does. And there it is. We got the pop-up message. And I think as it clears this pop-up message, it will then display the message. So pretty simple. That's a cross-site scripting attack. Let's just get a little bit more complicated here. And instead of doing the let's see if we can't grab some information. Document dot cookie. Everybody understand cookies in this class? Everybody got cookie? Everybody's good with cookies? We all understand where they go and how they're used? I see a yes, no, maybe. Okay. I mean, I've got a lecture on cookies. We need a lecture on cookies. But if not, document.cookie, document again, root of the domain object model. Cookie is the cookies that are, no, we do that. And there are the cookies that I got from my web server. Not that that's really useful. You can see a couple different fields. If you look at them, like, well, you can't see this at all. I mean, I can hardly see it. But that's a mixture of letters, numbers. Oh, that's all lowercase numbers. I don't know. Usually you can look for things that are base 64 encoded. Okay, so we did get something of interest. I mean, in that case, all we do is display it, but we could put it someplace. Get your cookies and send them off for cross-site, yes, some XSS attack. So there's an example of an XSS attack. I might also, let's see. Oh, yes. Now he has to ask, what did I call that? Please stand.
You can just browse the ASG directory, right?
I suppose I could, if I allowed that, if my web server allows it, probably does.
Yeah, it allows it. I tried it yesterday.
Oh, okay. Well, even easier is, here it is. It's, oh, XSS decode. That's what I want. How about that? There we go. All right. Let's just take a look at this website for a minute. We will look at the page source. There it is. It looks more complicated than it is. It just has a couple buttons, an input field, and then 3 JavaScript methods that are called show names. Simply takes the text. It will encode it, URL, encode data, and then display it in one of the fields. The show as is simply takes it, puts it in there, and displays it in the field. And the swap stuff method, there's 3 buttons. The swap stuff takes the value that's in the encoded field, decodes it, and writes it to the HTML page. So that's pretty simple. Let's just try it. So we'll try a simple thing here. Put my name, and we'll just press enter, and it up here's encoded, took the blank and made it into a space. And now if I do copy will just copy, it decodes it, takes, it was encoded, and decodes it, and so on. Okay, not real exciting to be honest. Oh, how about over here? No, we don't want that. We get lost. There we are. No. Oh. how is it that this, oh, not display was encoded. Excuse me, I'm sorry, somehow I lost. Encode or decode, I can't remember. Now we're getting really lost. Come on, don't do that to me. What did I call it? There it is. XSS decode. That should work. And it does. Okay. So if we put something nasty here, and the usual alert, because it's not that it's alerts are in fact probably the safest thing you can do, but they're there because it's obvious when they occur. We don't have to do anything nasty to my computer. Do something nasty. And you forgot to there. Okay, do that. Knowing you can code it there. We just show it. Oh, that that just nothing happened. I'm sorry, I have to pay more attention here, but oh, sorry. A-L-E-R, alert, that's how you spell it. Okay. Again, now we're going to. We just show that it doesn't. We copy it up there. Oh, that because we changed it. Okay. Well, it didn't quite show what I want to show. Anyway, yes, you can encode it. If you encode it and then show it or then copy it back, it does it. Okay, so that's cross-site scripting. Questions about actually running cross-site scripting? It does, as you can see, make things that's not okay. Let me hopefully the our web people can see the slides. Oh, let's try that again. Okay. Oh, well, okay. Yes, I think we're sharing. All right. We have a question. No more just sitting there. You're going to have to be awake. Our live studio audience has these little squares with numbers. You'll notice on the edges there are letters. Okay, those of you out in Zoom land, there is a Zoom question. Okay, I've got several of these embedded in the lecture. If you look at the paper, these, by the way, are called flickers. They have letters around the edges. If you hold the A up, that is, you want answer A. B up, you want answer B. And then, if all goes well, and I haven't even tested this, so I should have. Let's see how lucky we get today. P flickers. Press the four buttons. Okay, so think you know what your answer is? If you hold your thing up with the proper letter, which you believe is the answer, upright, you can twist them around, but hold it up with an A or a B, put a C or D up here. hold it up so I can see it. And then I'm going to scan the room with my phone, which will recognize your cards and tell me how you answered. Okay, let's do it. Everybody get your answer up so I can see it.
All right, so we first read the question or just.
Here's the question.
Oh,
Yes. I'm not gonna hide the answer from the JavaScript people. Okay, so you understand what we're doing? Everybody understand? I've asked a question. You're going to answer by holding this. Well, make sure it shows. Okay. Got an answer? So hold it up so my phone can see it because okay, please do it now. I got it. Okay, got you. Got yours. You're not holding up, so up wrong way. I can't see the back. And oh, gotcha. Okay. Bingo. All right. We have, including our folks online. Where did that poll go? Oh, there it is. Okay. There were 4 truths online, 4 truths here in class, and 1 false. Okay. First, we've got false. We've got to figure out how to do this. Misunderstanding. Okay, the answer: replacing an HTML paragraph with user input can allow arbitrary JavaScript to be executed. Unfortunately, 8 out of 9 people were wrong. The answer is false. Boy, I caught you. No, oops, not this. Okay, if you create a paragraph with user input, that will not run arbitrary text. You have to put it in an executable environment. You can rewrite the HTML, but if you just do a change, like we showed at the very beginning of the slides, if you just do a change of a text field, it will not execute. Maybe we didn't see it well on the pages there. If you do a document.write, well, then that rewrites the web page and interprets it. If you just do you set the inner HTML to a text file, if it's got script in it, it won't execute it. So the answer to this is false. Somebody figured it out or was confused, and everybody else got to pay attention. Okay, we understand? All right. There's more of them. Hang on to these. I'm going to try to use them throughout the semester, just to keep you awake. Okay. There are a variety of cross-site scriptings. Even more than the number of cross-site scriptings is the number of textbooks, websites that describe the number of types. You can look at Wikipedia, you can look at the 2 textbooks we have, you can look at other textbooks, you can just search for it on the web. And are there 2? Are there 3? Are there 4 or 5? It depends on who's counting. Your textbook thinks there are 3. I couldn't really define what the DOM-based cross-site scripting was. I looked at it, read it again, went out to Wikipedia, read that, and most sites will tell you there's 2 types. So we're going to go with 2 types, which are really simple: persistent and non-persistent. The non-persistent is also called reflected, and the persistent is also called stored cross-site scripting. So that's the same thing. The textbook has the main object mode-based, but nobody's really sure what that is. So we're not going to worry about that. We are not going to ask the question like, what are the 3 types of cross-site scripting? Which reminds me, I have rewritten Dr. Yuan's quiz for this week. The quiz was, she had 33 multiple choice questions. I went through them and decided I didn't like half of them. So I took out half. There's now 15 questions left. I added a few of mine. There's 15 questions. They are not all evenly point-based. The true and false ones have fewer points than the non-true and false ones. It still adds up to 100. Okay, so fewer questions. I think the questions are realistic, and they don't ask you to memorize picky little things that you find in the textbook that I thought the previous one asked for. I think the TA probably made these questions, just copied things from the slides. We'll talk about that. The slides has issues. Yes, you know, Why is this wrong? Okay. So, okay, let's talk about the different types. There's reflected, and reflected is also known as non-persistent. Basically, it takes something into the HTML and reflects it back. We saw that. We saw several examples of reflected HTML. It goes in, it goes out to the website, comes back, and displays that information. A lot of what my examples displayed it locally, but if you don't do take any steps to prevent it, if you don't try to look at the input, make sure that it's well formed, you're certainly vulnerable. And again, this is non-persistent, also called first order cross-site scripting. It says some recent browsers protect against reflected cross-site scripting, but I haven't found any examples of that. I didn't try too many. I tried Chrome. Chrome, it happens very well with Chrome. I didn't try Edge because I usually don't like to use Edge, but it claims it's more secure. Now, why would you want to do this? I mean, if you enter something in and it comes right back to you and it shows it in your web browser, well, so what? I mean, aren't you attacking yourself? Oh, yeah. What good is that? So let's think about it. There are examples. You can actually attack somebody else, particularly if I was to send you a sneaky URL that had you go out to a website and send something that comes back and does something nasty. In other words, you might send something to a website and have it returned, and in that case, do something that you didn't want. Let's see here. So email is a really common. Let's look at this example that I got from Wikipedia. Okay. Let's, in case you haven't got the characters yet, we have Alice and Bob. Alice and Bob are always in every talk about encryption or computer security. The characters Alice and Bob appear, and Carol is also often the attacker, although there are other attackers. But okay, so Alice likes to use the Bob website, bobsite.org, and Carol knows that. And so she creates this link, and you can see it calls the Bob site with a search, and it's got a query for puppies. So it's going to, that's how you might send a query with puppies. You send a query to the search site, and it's going to look up stuff for puppies, knowing that Alice likes puppies. But you'll also note that in addition to the query, she's added some script to this. And it's going to go out, and this time the script is coming from another site. You can put your JavaScript in some other location, and it will download it into the system and execute it. Obviously, for cross-site scripting, there's a limited amount of space you're going to have. You can't have a long and involved attack. But if you put it someplace, you can have just pages of nasty stuff that you're going to execute. So here it is. So when you get the Bob site, she sends this to Alice. Alice, of course. Oh, nice. Title cute puppy. So she clicks on that email, and it goes out to the website, and it executes that, and it shows her the puppies, but it also executes this, and this executes Carol's JavaScript that she hid in there. Again, it's reflected back to the site, because most sites are going to display the query. So the query was puppies. When it displays the query, it's going to display script. It's then coming from the website, so it's going to be interpreted. And so it interprets it and it executes that JavaScript. At that point, Carol now has, she's got Alice. Alice is the victim, and you can do multiple things. Steal Alice's cookies. So we know that Alice at this point is logged into the Bob site, and so if the stealer JavaScript file copies the cookies, sends it off to Carol, Carol can now use that to log into the Bob site, change the cookies, and then make the Bob site think that she is Alice, and she'll have all the authorization. Sometimes you go to a website and you don't have to log in because it knows it's you. This will know that it's Alice, but it's not. It's really Carol. Okay, so that's reflected cross-site scripting, where you send something out and it comes back. And in fact, as you can see, it can be dangerous to somebody, even though it's just coming back to the user. The other type of cross-site scripting is persistent or stored. This is where the attack script is stored on the server, typically on the server in some manner, and then displayed there. The most common use of this is where you have a chat site or a website where you put stuff out there, other users look at it. For senior projects, several teams have made websites. It's Aggie Chat or something, and they something, their own version of Facebook, where you put information out there and then it's displayed to other users. Unfortunately, almost all the students who did this didn't understand cross-site scripting, and they never checked for anything. So it was vulnerable. So the idea again is very simple. You put together a text attack that contains a script, the JavaScript, and you store it under your information. So imagine you have a website, like Facebook, that you can post information, other people can read it. So you post this, some text along with the script of an attack. And so when somebody else looks at your post, they see the text, but they also execute that script. And then, of course, it's now running in your environment, running on your computer, in your browser, with your privileges. And it knows that you're logged on to Facebook or whatever, and it can have all the access from your Facebook. It can send information back to the attacker. Well, by the way, Facebook is well aware of this problem, has been blocking that for decades. So they have other problems though. Probably read about it. Okay. So that's again typically comes when nobody filtering or sanitizing any of the input. Okay. This is a little bit more of a problem than reflected, because reflect again is one at a time. You do it and you attack once. Whereas if you store something out on the website, lots of people may look at it. You post something on your web page or your Facebook page, and lots of your friends all go out there, or friends now will be enemies later, go out there and look at it, and they all get attacked. And you can put it in many places where people look at it and they might attack many, many people. Message board. Oh, okay. And again, you can attack it, and you can also use this attack to drop other malware into the user's system. People have been doing cross-site scripting for a long time and are still doing it. A couple of years ago, British Airways, the largest airline in the UK, had a cross-site scripting attack that impacted about 380,000 transactions. So that was a couple of years before that. eBay had one. And then quite a while ago, Twitter had a couple of them attacked them. And so they were victim of that. So it's out there, and again, it is number 3 in the OWASP list. Okay, and here's another question. Where are the, oh, so how do I get out of this? Okay, those in the line, oh, don't want to do this. End. Polls. They say share results. Stop sharing. Exit. Polls.
So is there other question already stored in there?
Excuse me?
Other questions are stored in there?
Yes, I have a whole bunch of questions I can't see.
That might be in drop down, that drop down menu. Like right above the JavaScript in text.
Where do you see right below?
Just above the JavaScript in text. Yeah, that,
Oh, there, drop down menu. Oh, thank you. Yes, there they are. Okay. It was, every now and again, Zoom changes. And in an earlier version of Zoom, it worked differently. Caught me off guard. Okay. Let's shrink this so while people answer that way. You can think about this. And again, we're using the cards. Okay. Phone back on. Okay, everybody got an answer? So if you do, put your card up and let's try it again. Okay. I see one. Would you got an answer? Remember A, B, C, D. Put up so I can see it. You're not voting today. Yes. Do you have an answer? Maybe not. Okay. We got you. You. Oh, yeah, I got you. Okay. We're not voting today. All right. Okay. Let's see how our online participants. Oh, they're all over the place. You guys had two. So in total, there are 3 A's, modify, 3 stores user input. Nobody thought you could only pack one user, and somebody else said it was notice reflected. Okay, end poll. I just told you the results. Okay, the answer I like was stores user input on a web server for later display. It doesn't modify the web page on the server. No, you know that you're not changing the text of that file on the server. And of course, you're all correct. We mentioned you can access many users. No, this is persistent is not the reflected. Persistent is the persistent or reflected is the non-persistent one. Okay. Good with that? And make any mistakes? Okay. Give you a warning. I've been known to copy questions from the lecture and put them on the quiz. I had to write the question. I was getting some use out of it. Okay. So what can you do with cross-site scripting? Well, of course, we talked about stealing people's credentials. You can visually. And once you're there, you know, if you're running JavaScript, you can do almost anything. You can change different fields. You know, defacement means to change what the website is doing. If you have some political axe to grind, people are known to go out there, attack websites, and put some nasty message against the organization on the website. Trojan functionality is put something out there that will later, when you access, people will use something and it'll download some malware into their system, inducing user actions and exploiting trust relationships. Okay. So now, if you're an attacker, how do you find out if the system is vulnerable to cross-site scripting? Well, the easiest way is to put a lot of cross-site scripting attacks into the input fields and see if they work. So for all input fields that a website provides, put something like this out there. If you have multiple ones, you can put like check 1, check 2, check 3 for the number of ones and see which ones show up. Because people may be very good at blocking some of them, but not all of them. So you go out and find out. That's the easy way. You might have to look at the HTML, in other words, if that's returned, depending on how it's using the input that you provide. If it's using it locally, it's not working. If it's returning it, you have to see where you might have to do same sort of stuff you do in SQL injection by putting quotes and stuff to separate out the data. Remember, if you're going to put in quotes, it is almost always an even number of quotes, so it balances. And then you go out, you try this until you get something. As soon as you find something that reacts in some way, then you can go and further your efforts to see what you can do with that. Now, websites will take action to try to prevent cross-site scripting attacks. Well, obviously, because they're very dangerous. Sometimes you can get around those. There are attack signatures. Attack signature means, well, okay, we're going to go over each one of these. Sanitation and links. Let's just we'll go. Okay, signatures. A signature basically is looking for keywords, key characters, or things you can do there. So what you might want to do is, well, what is it concerned about? It's concerned about the brackets. It's concerned about certain keywords. I mean, is it bracket alone? Because a bracket alone might, you might have valid HTML, like an emphasis or a bold or something, and that goes through. So the brackets might work, but the word script might not work. So you might have to see how you can get around that. And of course, there's, you might code it, URL encode, and so the initial effort to view it doesn't see that, but later, as it's interpreted, it will decode it. Interesting enough, you can specify in the keyword in the Java, instead of just saying alert, you can go JavaScript : alert. And you go, oh, JavaScript. And that might not be, that may cause it to not be found. You can put cross-site scripting in CSS, cascading style sheets. For those who aren't web developers, cascading style sheets contain the styles of how the information should be displayed. The basic structure of a web page should be that the text to display is in the HTML, and the format that you want to use for displaying it is in the styles located in the cascading style sheet. The cascading idea is you can have multiple style sheets, and it, through some algorithm, picks out what style you're going to use. Also, another way to get around it is some browsers are very tolerant of bad syntax. XML has the requirement that XML must be correct. If you're missing a bracket or anything, it's wrong, the whole file is wrong, it won't touch it. Most of your XML interpreters will say, oh, nope, no good. HTML is interpreted by the browsers, and in order to avoid problems not being able to see web pages, most of your browsers are very tolerant of making mistakes. Oh, you didn't end this. Well, I assume it probably ends around here, and so we'll just let it go. So sometimes you can get by not putting everything the way it should be. Your defenses are looking for the proper spelling and all the things, but what's not there, and you can get by. You use the same sort of tricks that we talked about in SQL injection, how to get through. Again, here's some more how to get past those. You can encode the data. Here's that trick that we show where it's looking for the word script. So it goes bracket SCR, bracket S not script, and then it finds it here, so it removes it. Well, you end up with the word script again, unless they go back and do it again. No, comments, null bytes stuck in places will separate things. You can do backs. Now, there are systems that will escape them by putting a backslash before them, but sometimes they don't escape backslashes. So if you put the backslash, it will escape the backslash. Now, once you put it in there, there'll be two backslashes, and HTML will say, "Oh, you are supposed to put a backslash character here and not put in there." Yeah, so that will take it out. Okay, another trick I learned, this was really interesting, is use Unicode characters. Of course, the JavaScript operates in ASCII. It's a small character set because it's a programming language, it doesn't need a lot of characters. If you throw something in that doesn't have an ASCII equivalent, it will try to guess. Well, in Unicode, there's this double bracket character. This is a single character. Bracket. You use that in math sometimes. You might see that character. And so you put that one there, And of course, as it goes through a detector, it says, well, that's not a bracket. It doesn't care. The word script is there, but you don't have brackets. But the interpreter goes, well, okay, that's not a valid character, but I can interpret that as a regular bracket, and voila, it executes even though it's not what you think. Okay, another question, just to keep you on your toes. So all right, there out in the web world, here's a question for you. And there we are, folks here in class. Oh, okay. Got back in the phone. Okay, you ready? Get your numbers up. And okay, saw you. Got you. Oh, yes, got you. Okay. Oh, all right. Hey, we've got 100% agreement. Let's see what the folks online think. Yes, everybody says it's A, real good. I'm not going to show results at this time. We're just going to hide. Yes, the answer is A. It doesn't apply only, it obviously applies to HTML. It doesn't remove the JavaScript from HTML. You can, in your browser, disable JavaScript. If you do that, a lot of things won't work. I mean, it does make it very secure, but it makes it pretty useless. So that's one of the big issues of security. You have to find the fine line between functionality and danger. Okay. Some of the other techniques for fighting cross-site scripting is to limit the length of the input. If that seems to be the case, well, you try to use as brief words, as you can. Don't use big names. Use short little ones, and then you might be able to pull it in from another website. Get your stuff out on one of those little webs. There's the websites that provide short URLs, bit.ly or something, and others that provide, few characters. Well, put your nasty stuff out there and see if you can pull it in from that site. Okay, so we're not here to teach you how to be great hackers. We're here to try to teach you how to defend systems. So what do? It's not an easy thing because you have to get all the data. And again, we're trying to filter out the bad stuff, whatever it may be, and it may come from many places. It may come from user input, from databases, and so there's all sorts of things we can do. Let's look at a couple of them. Validate input. That's the simplest and basic one that you should always do. Look at the input that's coming in. Again, do the length. There's no reason to make it very long. If you're asking for information, think about how long might a valid answer be. Don't let the input be any longer than that. Look for character sets. A lot of things say, well, it's got to be letters, letters and spaces. That's it. Anything else? Maybe letters, numbers, and spaces. Anything else? Hey, what are you doing here? So, maybe a period, but watch out for, basically, also watch out for brackets, watch out for quotes, and ampersands. Those are going to cause you trouble. Also, you can get more specific into the format. Regular expressions. Being computer scientists, you should all understand what regular expression is, and you can define regular expressions for the data you want, particularly if you have things like an email address. Well, email addresses form a particular format. They have a text, an @ sign, a text, a period, usually three letters after that. So you can say, okay, if it matches that format, you accept it. If it doesn't match that format, then tell them to put it in that format. Same thing with other things. Account numbers, maybe account numbers are all numerical digits of a certain length. Make sure that they are. Don't let anything else go by. And then you validate input, and you can check things as they're coming out of the system, as they're coming from a database. Make sure that they are, again, clean. Looking for those bad characters, looking for keywords that might cause trouble. Encoding things may or may not help you. If you encode them, it might keep them, but a lot of systems decode. As soon as they come, browsers see encoded things, well, it's going to decode it so it can display it properly. People don't want to see the percent signs. You need to do both. Combining both of them, input and output, involves 2 layers of defense. And then watch how you get things. And again, don't execute user data. That is the root of all evil. So avoid that. Let's see. We didn't talk too much about event handlers, but you can also, instead of just putting script, you can give an event handler. Event handlers, there are several of them in HTML, such as on focus or on change. That means that you specify for this particular field, like on change, as soon as it changes. I use that in my example. As soon as I type something in and hit enter, it executes the method. You can have on focus, meaning as soon as you go there, as soon as you click on it, or as soon as the cursor moves to that field, it's now that's the field in focus, and then it will do the on focus action. And these are really nice features in Java or HTML, so that you can do all sorts of cool things, but they do have problems. Oh, we got another one. I'm just not letting you go. Oh, back up. So, online people. This is easy. There's only two possible answers. All right. Get my phone. It's kind of a cool application that does this. You have to think there's 25, 5 by 5, 25 squares. It's binary. So there's 2 to the 25 possible numbers or possible squares, right? But you have to make sure that they're unique in rotation. Not only each one of yours is unique, but each rotation is different from everybody else's rotation. Okay. All right. And then when you pop it up, it tells me which card. Hang on. Okay, that you go. All right. Oh, okay. Let's see how our poll is doing online. These people gave me 2 falses. We've got 5 falses and 2 trues. Well, okay. I like false. No, sanitizing the input is a good start. It's a necessary start, but it's not sufficient. Data can be coming from a database where somebody's put it out there before. You have to watch everything. So yes, sanitizing the input is important. It's not the end. Okay, HTTP injection. Let me not talk about HTTP injection. HTTP injection was in the website, excuse me, it was in the textbook. It wasn't Dr. Yuan slides. I went out and tried to do it. I write little programs to try this stuff. HTTP injection doesn't happen. When I look at their examples in the book, why did they ever expect that to happen? There's no reason for it to do what they say it does. And then I went out to OWASP. OWASP doesn't have anything on HTTP injection. Go out to Wikipedia. Now, Wikipedia does have 1 4-sentence paragraph on injection. Kind of old. It doesn't say much about it. You Google around, you don't find hardly anything about HTTP injection. I don't believe it exists. Now, remember, you have 2 textbooks. One of them is 10 years old, one of them is 14 years old. It might have been a problem a decade ago. It's not a problem now. So we're not going to worry about that. Here's what they thought it was. They would say, okay, given that you have URL like, okay, this is a get command coming from the browser going to the server, making a request, and then the server is expected to respond, yeah, okay, and take this value that you sent as user ID and put it in the cookie. Easy enough. Now, HTTP injection is supposed to, if they put a character return line feed, it's end of the line in there, and then add this, that somehow that would end up in the response. I have no idea why they thought that would end up in the response. It turns out that what happens is the character return line feed, foo bar, is all passed to the application as text. And if you print it out, it does character return line feed, but it appears as text to it. So again, do not insert user controllable data into HTTP headers. Now let's think about that for a minute. You can't put user data into an HTTP header. Well, how does the get command work? The get command goes get something and then parameters. What they're really saying is you can't use the get command. Well, hey, let's just shoot down the web. So that's not going to happen. So not to worry, you can bet the HTTP header injection will not appear in any quiz or the exam. I have pulled those questions from the quiz. They will not appear in any future exam. I just think it's something that might have been a problem in the past. It certainly isn't now. I got out the OAuth Z proxy that watches things going back and forth and modified it it just doesn't do anything. And I got the web in the web pages, it just the character and language just passed as if it was text to the application and passed back. So yeah, it doesn't do anything. But what does work is redirection attacks. Redirection attack is where you convince the website to switch to a different website. Now, this is a feature of HTTP and HTML, the web system. You can say, don't look here, look over there. There is the response, the location telling you, we want to go, here's the 300, I think it's 300, says moved or go to this new. Yes, you can say moved over here, or move permanently, or move temporarily. It just says go to that website, and your browser will just, oh, okay, you want me here, go over there. It's useful a lot, particularly for changing websites, or I use it a lot for error messages. I got error pages. Instead of trying to create them, when there's an error, I just say, oh, display that error message website. But it is possible to convince the browser to go to a evil website. And that, of course, causes you all sorts of problems. So you can redirect to a third party. A lot of it depends on how does it get the information to where to redirect. It is, of course, possible. You can write an application where you ask the user for some information, and then you use that to create a URL, and that's where you go to. So that's not good. Again, refresh header, there's other tags. JavaScript APIs, document allocation can be used. So to you look through the application, see what they're doing. Again, using the proxies like that. I think you're using a different one in this class. When you're attacking TuneStore, you're using a HTML. Excuse me. Okay. Yes, it's something that shows you all the requests from the browser to the server and back. Okay. Yes. To be honest, I know very little about TuneStore. I know Dr. Yuan and some of the people in this department kind of came up with it, or took it from Charlotte and ran with it. I haven't used it. Those of you who in my other class know that I use the OWASP WebGoat. WebGoat is another vulnerable website. I don't run it in a virtual machine. You just run it on your own system. It works pretty well. But since Dr. Yuan is using TuneStore, we will continue to use TuneStore. But there are ways of watching everything that goes across. And that would be an intercepting proxy. Okay. How do you prevent it? Well, again, never execute user data. Watch out when users give you some input, don't put it in a website and go there. That's going to cause you problems. You can also avoid redirection by putting links, just a URL link. You click on that, that's going to go to the website that it says it's going to go to. It's not going to do any redirection. It's much more difficult to fake. And also, if you want to go to a different website, you might make a list of where you want it to go. And then the application will send an index into that list. In other words, go to a website 3. And then you index into the website, get the URL, and go there. It's very easy to test that you're going, the number that the user gives them is not negative, doesn't go beyond the number of things you have on the list. And then let's go there. You can also try to validate the use of supply URL. That's, again, difficult. You try to look at the URL, parse it, and decide if it's good or not. That's challenging because it's sometimes very difficult to tell good website from bad. All right, I've come to the end. Lucky you, we are done for today. On Wednesday, we'll talk about cross-site request forgery, but I still have some questions. I have some questions for you about how we run this class. So here's a couple quick questions, if you would. Out on Blackboard, Dr. Yuan has the slides, and I have been putting these slides that you're looking at this afternoon are out on Blackboard under Unit 10. I can put them out on PowerPoint because Dr. Yuan put them out on PowerPoint. But do you want them on PowerPoint? I could also put them as a PDF. I could put them as an image or whatever. So let's okay. Obviously, there's no correct answer here, but I do want to know your opinions. Could you put your way up so I can get around her? Thank you. Okay, and yeah, got you. Okay, PowerPoint is 3-2 here. Let's see what our launch. Sorry, I bet you that's what the chat was telling me. Option, okay, they voted option A. So we now have a 5. And out there on the website, I apologize for not putting this out there. Okay. One. The other one want to vote? Okay, we got them. Okay, well, it's 5. It's 5. So most people want PowerPoint. Somebody wanted PDF. I suppose I could put them both out there. But PowerPoint works for you. It works the easiest for me because I would say I make these things in PowerPoint. And we go, all right. So next question. Yes. How the videos from previous classes. We can I put them out there. I mean, I've been recording these. We put them out on the website. Dr. Yuan always recorded hers and put them out on Zoom. Where do you want them? So, whoops, was it? Okay, got you. Okay, all right. And let's see what our online participants are mixed between Zoom and Blackboard. Okay, we have 1 vote for Zoom, 3 votes for YouTube, 3 votes for Blackboard. And thank you. Nobody says you don't care. Why would you care? You saw the live. You don't really need to see them. So
probably it might be easier for you to put it on YouTube, right? Because you just have to upload it right now.
yes, I have a YouTube channel. I got my YouTube. So I'm probably going to put it on YouTube. The Blackboard will have a link to YouTube. So if you click on the Blackboard, I can, even if I get really fancy, I can put the big link with the picture of the, but I probably will just put a link. Yes, so okay. So we'll not do it on Zoom. We'll just do it on Blackboard or using YouTube. You all watch YouTube. Actually, you know, YouTube has earned its billions of dollars by becoming good at showing videos. So they have a pretty good user interface. So we'll just use YouTube because it works well. We want to give our billions of dollars to it. Okay. Does anybody have any questions about cross-site scripting? There is a quiz, and again, it is due Sunday, October 31st by midnight. You do it whenever you want to. It is short. It's only 15 questions. They are reasonable. I think they're reasonable questions. I filtered them out so we don't have questions I didn't like. Maybe in the future, I don't know. I might get rid of the multiple choice questions. I'll have to see what I can find. I know you don't want me to get rid of the multiple choice, but yes, your graduate students shouldn't be answering multiple choice questions. There's things about education where there are people educated. You ask questions at different level. Questions that we have from previously are kind of at the lowest level. Do you remember reading this? I'd rather have questions that ask you to do things. Do you understand how to use this? Can you evaluate different options? So we're going to, anybody's ever heard of Bloom's taxonomy? That's what I'm talking about. So if you haven't heard of Bloom's taxonomy, waste 10 minutes and look it up on the website and read about it. It's an interesting thing about education. Okay, so that's it for today. Hey, I hit it pretty well on the time today. So that's it. Again, today's material was in chapter 10, no, 10, 11?
Yeah, I think it's 10, because we had 9.
Well, you'd think so, but I think actually it jumps to 11. Well, anyway, it's the chapter in the textbook. It says, oh, yes. Tell you what, it says, so right in the beginning, what are we reading? Oops. There we are, chapter 12, and part of chapter 13. We covered the chapter 12 stuff today. Chapter 12 was on cross-site scripting. Chapter 13 talks about cross-site request forgery, and we will talk about that on Wednesday. And that, of course, is the chapter 13 material. I must admit, there are 70 pages in chapter 12. That's kind of a lot of reading material. You can skim over that. I think we covered everything that I thought was interesting. And I took out the questions that I thought were asking, picky little memorization things that just pointless. And I know, I mean, I had children who are probably now older than all of you. I watched them go to school, and they didn't read the chapter. They looked at the questions and they searched for the answer in the book and put it in. I know how it's done. So I'd rather you read the book and then go back and answer the questions. Okay, that's it for today. Any questions out there in Zoom land? Oh, we have a question.
On Blackboard, it says we have a project like 5 due on Sunday and then project 6.
Oh,
next day.
yes, let me change the dates. Again, the dates are off. I got the quiz dates. The quiz dates are right. But yes, I will try to change the dates in there. By the way, in some places it will tell you correctly that the different questions in the quiz have different numbers of points. In other places, it will say they're all the same. Well, I can't find that text where how to edit that text that says they're all the same. I've got the other ones and I changed it to say they're different. So they are different. Some of them are 8, some of them are, well, some are 7, some of them are 6 points. Not much different, but they are different.
I have one question. We are done with SQL, right? So can you give the solution how you got into the system? Like,
Oh,
as a
yes.
SQL injection?
Oh, yeah, we got 1 minute here. We'll just do it. Okay. Again, that. Oh. Remember where that was?
Form 25 login.html.
Quiz 9 login. That looks good. Let's try that. What did you say it was?
I think it was form 725 login.html.
That or was it? Yeah. Okay, I don't remember what it was.
It's quiz9 login.html.
Yeah, there it is, quiz 9. Okay, let's try it one more time. I think I typed that in. ASG. Oh, there we go. Found it. Yes. Okay. Put my student ID number. Well, there's my student ID number. Now, we don't have a password. Well, we can see how it's put in. So we're going to put in, we're going to end the field. We can put in something, you know, that end that field, and then go or quote X quote equals quote X. Now, again, even number of brackets. There's going to be a closing bracket that we've taken out. So try it again. And we got it. Good with that? Okay. And the server side of this, once you get it correct, takes the ID, puts it in my database and says you did it. So I'm just going to go out to the database, sort through your numbers, and then I got a lot. Link your numbers up to your names, which I can do somehow, and see that you did it. Okay. Is everybody good with that? Again, let's see if I go back with that. There it is. Again, name. This is actually optional. The quote is important. The quote ends the field. The or, again, this, you know, X equals X. So it's going to be true. So true or anything is going to be true. So it doesn't matter what you put in for a password. It's going to be true. Put this in quotes. Leave off the trailing quote. I used a text field instead of like saying 1 equals 1 because I have to have a trailing. Remember, it's putting this inside quotes. And so this quote ends the first quote string that then is interpreted by SQL as part of the SQL request. And then there's a trailing X, you're putting inside quotes. This is a quote that the program is going to use to concatenate with the rest of it. So you have to put the quote there, otherwise you get a syntax error. It doesn't work, but that's it. Okay? Yes, thanks. I'll try to make sure. In fact, I believe the quizzes all tell you what the right answer is as soon as you do it. And like before, when I made the quiz, I stole most of the questions from Dr. Yuan's earlier quiz. If I liked the question, I kept it. If I didn't like it, too bad. And it tells you the answer. You get to do it once, and that's your grade. You can do it again, but it won't score you. The first time you do it is what scores you. So you can look at it again and again if you want to go back and review it for some reason. But does that seem an appropriate way to run this, or do you want to do like the last one? Or okay, I'm not going to tell you that. Well, we do the last one. I'm not going to tell you the answer after the answer. Correct answer. Okay, so that's it then. Any other questions? We'll see you Wednesday at 3. Okay. Goodbye to Zoom.